Hey guys, welcome back to my channel. Thank you very much for joining me. If you are new here, please check out my other channel, Alka Talk, and subscribe to it. Leave a comment, watch a video, and we will be forming a new community apart from this maths channel. Nonetheless, let's get right into it. So the paper 3 was requested by a lady. I can't remember her name. I am very sorry, but I am here with your solution. So the question says, the diagram below, not drawn to scale, shows a flexible piece of card in the shape of a sector of a circle with center O and radius 18 centimeter. As you can see, the diagram is here, the radius. So if here is 18, OR is 18, that means OP is also 18. All right? And the angle here formed is 140 degrees. This is not drawn to scale, guys, so don't pay attention to that. We're asked to use pi as 22/7. So no 3.142, 22/7. All right, and we know that this will be the length of the arc. So it says, show that the perimeter of the card is 80 centimeter. Perimeter of this, guys, means the distance around this shape or this sector. We know that we have two radii going on here. So 1, 2. And the perimeter of a sector is equal to, put right here, so perimeter is equal to 2r plus the length of the arc. Okay, how do I know that the 2r will be the two radius and the length of the arc would be this distance around here? And we know the length of the arc is calculated by theta over 360. That means the observed angle over 360 times 2 pi r. Okay, guys, you're going to add the 2r to that. So we use using this formula, we're going to prove that the perimeter is equal to 80. So let's substitute what we have. So perimeter is equal to 18 plus 18 plus theta here is 140 because the angle they use, theta over 360 times 2 pi 22/7 times r, which is the radius, which is 18. We can go ahead, guys, and simplify this. Remember, this is a paper 3, so you'll be able to use your calculator. However, my calculator is dead, the battery is out. So I'm going to work this with my hand and, should I say, my brain. So 18 into 18 goes 1, into 36 goes 20. 7 into 7 goes 1, into 140 goes 20. All right? What else can I cancel? Dun, 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 dun. All right, let's go. So we know that 20 cancel 20. That's 44. So 2 times 22 is 44. 18 plus 18 is 36. 36 plus 44 is 80 centimeter. And that's our perimeter. So this is proven. Alright, guys, I hope you understand it so far. Let's go to the next question. So it says, calculate the area of OPQR. I'm going to bring it back so you can see what we're talking about. So OPQR is basically the area of the sector. So let's go. We know that area of the sector, I'm going to put it right here. So area of sector is equal to the observed angle over 360 times pi r square. So perimeter, guys, is the same thing as saying the circumference. Area is area. You know, perimeter is pi r 2 pi r or pi d, and the area is pi r square. So let's go. We know r is equal to 18. You know, the angle is 140 from the diagram we used, and we know pi is 22/7. So let's substitute what we have into the given formula. So 140 over 360 times 22/7 times 18 times 18. All right, because r squared means 18 times 18. You're going to be having your calculator with you guys. so you can able to work this out in your head. However, I am going to work this as is. So I'm going to say 7 into this goes 1, into 140 goes 20. I know that 20 into 20 goes 1. 20 into 360 goes 18 times. This 18 can cancel this 18. So we have 22 times 18. 22 times 18 will give you 396, and that is centimeter squared, because we're talking about area. Alright, so the area of the sector is 396 centimeters squared. If you understand this question, guys, leave me a comment in the comment section below and let me know. If you don't understand, please do the same so I can do my best to help you along this journey. So the next part of the question says, the card is bent and the edges OP and OQ are taped. So just imagine, guys, that this diagram is folded. So OP and OQ form. So it's basically forming a cone here, guys. If you can picture a cone, it's basically forming a cone. So they say that so they are taped together to form a curved surface of a cone with a circular base PQR. Draw the diagram of the cone with perpendicular height and the radius. So we know that when you can use your ruler to draw this guy. Well, I haven't got no ruler right now. So I'm going to be using my hand to draw it. So that's my cone. Alright. So the slant height will always be the radius. And the radius will be here, will be 18 centimeter. Alright. From that to that. But perpendicular height is basically the 90 degree, the height that forms the 90 degree. So this is the slant height. So the perpendicular height would be right here. Alright. To form the 90 degree. And so that's our H. We know the circular part here, that's where the radius will come in. And so you can draw your line from the center to any part of the circle, because that's radius. Like anywhere when you want to draw your R, that's also fine. And so this is basically how your diagram will look if you should sketch it properly. Alright, guys, and so we drew the cone with a perpendicular height labeled and the R for the radius also being identified. Alright, guys, let me know if you understand these questions so far. The next question says, calculate the radius of the circular base of the cone. Alright, guys, so right here in the first section we found, so the radius is basically be formed from the length of the arc, right, guys? So they want the length of the radius of the circular section of the cone, not this part. And so some people will say 18. It can't be 18 because that's not going to be that's basically the slant height. And so, guys, we know that for the perimeter of the circle, we found it to be 44, because if you should work with the length of the arc, because that's where the radius is basically formed from the circular aspect of it, PQR, around here. So we found that part to be 44. Let me know if you understand this part, guys. So the circumference we know here is 44. Alright? The circumference of the cone, or the perimeter of the length of the arc, is 44. And so if we know the circumference is 44, so circumference is equal to 44. And we know the formula for circumference is equal to 2 pi r. Okay? So if we want to find r here, we basically transpose to make r the subject. So to make r the subject, I'm going to divide by 2 pi on both sides. So that cancels that. R is equal to c over 2 pi. Alright, guys, I hope you're following so far. Let's put in what we know. We know pi to be, and put it right here, 22 over 7. So we'll be using this for our pi. We know our circumference is 44 and the 2 remain the same. So remember, once they're dividing, guys, we go ahead and we put it using the division sign, keep, change, flip. And so this will be c times, we're going to flip this, becomes a half. How do I know that? Because 2 is basically 2 over 1. And if you flip that, becomes a half. The pi is 22 over 7. If you flip this, it becomes 7 over 22. Alright, guys? And we know the circumference. I should have put the 44, but never mind. The circumference is 44. So it's 44 times a half. So it's basically 44 divided by 2 times 7 over 22. Or I want to say 44 times 1 over 2 times 7 over 22. Alright, guys, so let's simplify right here. 22 and 22 goes 1 times, into 44 goes 2. This 2 cancels this 2. So R is equal to 7 centimeter. Let's try using this way. 22 into 1, 2 into 2 goes 1 times. 2 into 44 goes 22 times. 22 cancels 22, and so 7. So it gives you the same answer, R to be 7 centimeter. So let me go again, guys. You first identify the circumference. If you didn't know this, you go ahead and use the theta over 360 times 2 pi r to find the circumference. Alright? Because it's a sector, and that's why the angle here is identified. So having the sector, guys, you find the circumference of it to give you 44, and then you go ahead and transpose or make r the subject, which is c is equal to c divided by 2 pi is equal to r. You put in what you know, where r is equal to, not r, where c is 44, pi is 22 over 7, and the 2 is the same. Then you go ahead and you simplify that part. Now they say use Pythagoras Theorem to determine the height of the cone. So guys, we just saw how this cone would look if it should close up. Alright? And so we want to find the height of the cone, the perpendicular height. So from the vertex, from the apex here, down here, we can see a right angle triangle coming out right here. If you can see the right angle triangle coming out, in order to find this particular height. Alright, guys, so I'm going to be drawing this triangle on the other page and putting what we know. So let's move right into it. So I'm going to draw it right here. Remember, it's not drawn to scale, so please forgive me. So that's 18 centimeter. We found R to be 7 centimeter. We want to find the height. Alright, guys? And it's a right angle triangle, so we can apply Pythagoras' theorem to it. And we know Pythagoras theorem says the length of the two short sides square. If you add them, you should get the length of the longest side. So I'm going to give this a labeling. So I'm going to put P here. I'm going to put P here. I'm going to put Q here. Alright. So let's go, guys. So the length of the two short sides square. So we know that OQ squared plus QP squared is equal to OP squared. Some would say A squared, B squared, whatever what they want to call it. I don't use that because the triangle will not be always called ABC. So let's work with this. So OQ squared is H. So H squared is equal to OP. Let me say equal. So 7 squared is equal to 18 squared. Let's go ahead and find H. So I have to subtract 7 squared from both sides. So 8 squared is equal to 18 squared minus 7 squared. We want to find H. So we're going to find the square root of both sides. So this cancels this. So H is equal to the square root of 18 squared. It's going to give you 324 minus 7 7 is 49. This will give you 275. Square root of that will be 16.6 to be exact. But if you want to, you can leave your answer as the root of 275. It's up to you guys. But you have to know you have to know how to round off and when to round off. So I'm going to leave this with 3 significant figure. And so in the solution, I'm going to write 3 sig fig. Alright, and the unit centimeter beside it. Alright, guys, and that's basically how we solve a question like this one. If you have any questions, feel free to leave it in the comments section below. Reach out to me on Instagram. Email me. I am happy to help you. I am always here to help. Alright, guys, so I'll see you on the next video. Need more paper 3? Please tell me.